In terms of what we're going to go today, I wanted to take some time to kind of enumerate some of the things that we're saying. We wanted to, make this risk-based case for it. So we wanted to talk about some of the actual threats that we're seeing and what we're doing today to kind of protect against those threats and, what is and what isn't working. We're going to dive into this idea of MFA and that not all MFA is created equal. I think that'll make sense when we get there. We've got a library that we've created over time of various different access exploits, and actually going to take you through one of them, as an example today, just to put a real face on some of the conceptual things that we'll be talking about, and then we'll move on and talk about what actually makes, for those of you that have been following along, particularly in the MFA world, or following some of what Department of Homeland Security, or more specifically the CISA folks, have talked about as fish resistant MFA. So we'll talk a little bit about what makes something fish resistant. And we'll also continue to talk about, the important role of device trust and how that plays in. And then we'll follow up with, a little bit of an idea of what all of this together might look like, something that we call Zero Trust Authentication, what it might look like in action. And we'll actually do a demo there as well at the end. And then I'll jump into Q&A. So without further ado, let's get started. This may look like some of your environments. We've got, one of the issues, that we all know about is the ability for phishing attacks to be successful. And a lot of people, a lot of our customers have done a lot of things over time to try to improve that. So kind of in the email sphere, we talk about, putting in spam filters and, doing some fairly sophisticated things, even using machine learning and AI to better classify that, doing DMARC rules and things like that to try to, avoid getting, spammy stuff from places where it shouldn't, reputation, leveraging threat intel, et cetera. But the real point of this slide in the next couple is what we can do is we can reduce the problem, but we're not actually solving the problem. So, whether it's, one user that clicks a link and logs into a, potentially malicious site, or if it's a larger number, the bad guys are winning. They have to, they have to get through all this stuff, but these are kind of what I would call a set of probabilistic controls. They reduce the problem. They certainly weed out a bunch of stuff, but they don't solve it. That's not to say, by the way, I'm not trying to throw any of these under the bus. I think, having, a defense in depth strategy in place makes sense. This, when we're talking about email in particular, makes sense. And then there's some other things that people have tried beyond it. But, if we only get 5,000 emails and really are able to reduce that, it looks one way. If we get a lot more emails, if it's a kind of a 10x, scenario, then we've got, 10 people into or clicking on malicious links. And what if it's 500,000 email? Then we've, the problem just expands. So this is, certainly a part of the kit that most organizations will implement. But now when we expand that out and talk about this, because since this is a multi-channel problem, it's not just email, it's, text, SMS stuff, it's Discord channels, it's social channels, et cetera. So all of those, play a part. And a lot of us have talked about this, idea of the expanding landscape that we have to protect against. And, this, I think, illuminates that in a big way. So, we can't have, all these, or even if we did, and one of the things that I've always done, since my analyst days was use kind of the magic wand test. If we implemented these controls perfectly for email, if we were able to implement additional controls like this across some of our other channels, we're still only reducing the problem, not cutting out a class of problem. And how confident would you be if you filtered all that stuff out that one of your employees wouldn't click? Taking a page out of the honesty book here, this is actually, we're a know before customer. So one of the things that we use is training and user training on, spotting malicious phishing emails, looking at malicious links, et cetera, but potentially malicious links. But even in that, we're not perfect. In fact, we went from, not so great 7.1 down to 6.4, but we're still not at industry average. The good news is we've got a set of controls that you'll see in place that still protect us in this regard. So even if those fish type messages get through, we've got some other controls in place that'll backstop that, which we'll talk about. But I'm sure many of you look like this. You use a set of filtering, you use a set of training types of things, but you're never going to drive this all the way to zero with a set of probabilistic controls, and we know that to be true. I mean, we know that from all kinds of reports that we see, whether it's the CrowdStrike team that does an excellent report every year. I recommend you actually read their threat report every year, or the Verizon data breach report that's going on, I think, more than a decade now. Some of the same things come up year after year after year. They've been the same for a decade. So, we know for a fact in 2023 that 86% of the web application breaches that they looked at, and these are actual breaches that happened in the data breach investigation report, 86% of those involve stolen credentials, typically as an initial access vector. That's actual data. That number fluctuates around every year, but it stays high, basically. The second side is actually one that I lost a bet to my CEO on a little while back, and we were having an argument, and then he showed me this one right out of the Verizon report. But basically, how do ransomware breaches start or happen? And my inclination, as a cybersecurity guy, was, oh, somebody clicks on a bad link, it directly installs a ransomware kit that then migrates, et cetera. And the reality is that certainly is one of the ways that it happens. But the top way, the top initial attack vector for ransomware is the use of stolen credentials to log in to desktop sharing or other remote access kind of software where the bad guy can then deposit the ransomware, or maybe they'll even move laterally in the network and get to a particularly juicy target and then go. But the initial attack vector there is the same. So we know, for example, that passwords are just not cutting it in this case, and that's not obviously new news to anybody. But I just really wanted to take a data and risk-based view of this rather than a preachy view. So kind of where we are in the state of play is we've got these first set of controls that we talked about, email filtering and proxies and mail server, better configuration of our mail servers, et cetera. And that's kind of one of the first lines of defenses. And then, one of the other lines of defenses, particularly protecting against the issue with passwords being an easily phishable credential, was MFA, or what we've put here is really traditional MFA. And when we talk about that, we're talking about, one-time passwords, one-time tokens, push notifications, or even things like number match. The problem is those traditional MFA, and what I'm talking about is the 99% of MFA that's implemented at companies, today, just doesn't take care of this idea of credential theft, and we'll dive into this in more detail. And it doesn't stop the attacker in the middle, kind of the phishing-based, proxy-based attacks, and or side channel attacks when we're talking about push notifications. So the end of the day is, even with these two control sets, we're still in a probabilistic, category, and the answer is, as we've seen, the bad guys are getting through, and that's pretty well known. I know many of you follow the news pretty closely, particularly your different channels that talk about cybersecurity. On the left side, we've just got some of the headlines. And these aren't just attacks. These are attacks that included MFA bypass. So part of the attack, part of the TTP was to go around, above, over whatever MFA that was in place. And it's interesting, if I go back, about a year and a half, had lots of discussions with various CISOs. We're involved in a couple of different CISO networks, and we were pushing this pretty hard, kind of, and I got a lot of pushback. Quite honestly, we got a lot of pushback about, hey, Patrick, it really can't be that bad. Are we really seeing this in the wild? Microsoft says MFA blocks 99% of attacks. There's some Google numbers that are similar. And the reality is, yeah, it really happens, and kind of what a difference a year makes. In this past year, in 2022 and 2023, there's been quite a bit, whether it's, CrowdStrike, showing reports that, really shows this is a problem that's active and in the wild, or Microsoft coming back around and talking about, the 10,000 organizations that were being specifically targeted with attacker in the middle kind of techniques that we'll go into in a bit here. So yeah, it's a real problem. This isn't theory. This is actual problem that's happening today and happening at scale. We're not talking about the realm of the sophisticated nation state hacker to do this. This is really dropped from that level of attacker down to, your garden variety financially motivated attacker. All right. So let's look at kind of a couple of categories. When we say not all MFA is created equal, it's because they're using a technology or an architecture that is open to various different kinds of attacks. So on the left side here, we've got a set of social engineering attacks using different kind of pretext, some ruse to get somebody to click on a link, whether that comes through email, chat, or SMS, or using what's becoming known as prompt bombing, sending lots of different requests to an end user, having those end users, get push fatigue. I've got, when I started talking about this in some of the CISO and some of our security engineer discussions we have, just about everybody raises their hand and said, yep, one of my guys, including, too often, some people with, relatively deep, or privileged access to things, kind of, fell prey to some of the prompt bombing and push fatigue attacks. So there's one class, and the idea is any factor, that is a password or a password by another name, whether we're talking about, a one-time password, a magic link, et cetera, or another knowledge factor, for example, the color of the house that I grew up in. Any of those things, are just weak factors, and we'll talk a little bit about those. The other thing is there's phishing kits that are pretty easy. So by the way, when I on the weak factors, any factor that an end user, to put that context around that, any factor that I can get an end user to give me, like over the phone or over an email or share with me, is by definition a weak factor. It's a shared secret and not good. On the phishable side, this is where we've seen a lot of improvement, if you will, in the TTPs that the attackers are using. And the reason is there's really easy to get phishing kits. Right here, we've got one called Evilgenics 2. That's one you can, I've got the GitHub, link in here. You can just go search on GitHub and download this. This isn't something that's, necessarily sold in the deep underground where it takes a lot of skill to go get. And there's a bunch of other attacking kits just like this. So this is one of the more popular ones in which you can launch, basically a man in the middle attack. Before we jump in and talk a bit about how that works, if you guys are playing along at home and you've got your bingo card out, we actually have to say something about AI. And since I think every cybersecurity presentation for the last 6 months has done that, but kind of putting that into the context of what we're talking about is AI is just going to make this worse. We talked about a set of controls that were probabilistic, and the fact that we're often relying on users as part of that. Well, the level of difficulty for the bad guys to pull off these attacks when they can, use AI to help them code things, is going to go down. The spear phishing lures themselves, and we're already seeing this, are getting much improved. Certainly gone are the days of the noble prince in Nigeria and or other phishing lure emails that we get that are, full of grammatical errors and mistakes. We can create very nice lures that are, grammatically correct, or even in the right tone of, northern or southern in the U.S. or written in the Queen's English, for example. And they, so that's going to happen. And then, what that's really doing is the time of exploitation from a new vulnerability is going to go down, with some of these tools. So those are some things that I think, we see in terms of the way AI will impact. As an interesting little exercise we did, our CTO, Jason Casey, has a pretty nice LinkedIn profile. I grabbed that profile, and then we used this prompt on the left, dropped it directly into Chat GPT, and asked it to effectively give us a phishing email. Now, ChatGPT and some of the other ones actually have some guardrails on it, so it so they try not to do malicious things. It doesn't take a whole lot of work to try to work around those guardrails, as you can see here in our prompt email on the left side. And what the result was three different emails that we could use, and this was probably the best of the three that we took. And this really talks about, Jason's involved in a lot of different cybersecurity and groups, and this used just one of the groups that is fairly prominent, and harkened back to some things. So created a very well crafted and very believable email. So that's kind of an idea of the result of that. And like I said, that was only one of three responses. So let's talk a little bit about kind of the exploitation of these and how this actually works. And I'll really jump into a demo here. So we've built up a library of exploits against different kinds of different kinds of MFA, different kinds or even different tech, so different companies, et cetera. I'll pick on the Microsoft guys, but they're in good company. Like I said, the vast majority of MFA that's being used in production today is susceptible to a lot of these technical techniques. So this isn't something that is just affecting the Microsoft guys, for example. All right, so I'm going to stop here. Let me give you, kind of a little bit of an idea of how one of these man-in-the-middle, proxy-based attacks will work. And so this is kind of directly out of our threat, attack library. So the first thing, we're using EvilGenix. Oops, let me back up there. Where we're using the EvilGenix kit, as it says here. We set up an environment that looks like a lot of the customers that we work with. So it's an Azure AD environment using Authenticator and the passwordless version of that. And then we're using number match and biometric, and still able to very easily get around that. So let's first start with how does this thing work? So the actors in our play, the victim, the attacker, and the proxy. This will go through the different steps as part of this attack. We'll share the presentation out so you can take a little bit more time with this. I'll pause it there for just a second. So there's a set of steps that happen. The phishing link goes out. The victim tries to log in, provides credentials. We capture the proxy captures credentials, passes those on to the service that the victim was trying to get a challenge, an MFA challenge, in this case a number match, push notification and/or a number match. In this case, it's a number match. And then they provide the response both to the legitimate server, and then it's at that point, since that traffic is being routed through the proxy, that we can grab the session cookies and reuse those and then do a session hijack. So let me show you how that looks. We're going to start off with a phish, show a legitimate email. Our victim is doing work, gets the email, clicks on the link, looks legit, logs into the service, to get to the data. We do the number match, as you'll see here. So we did the combination of the passwordless authenticator and number match, and then we're in. So the good guy's in, but also what we left is this residue in the proxy server, which was the session cookie. And then we're going to take that session cookie and inject it right back into the application. And now our bad guy is in. And it's kind of important to note in that is the bad guy could be anywhere. With this kind of attack, we're not stealing and reusing the credentials. We could have done that too. In this case, it was passwordless. We couldn't reuse that credential. But if it was a password base and say a one-time password, we could steal the various credentials and log back in. But this one just actually stole the session cookie and injected that back in and reestablished the session, which could be done from anywhere. Now we're working. The login authentication flow is done. We can log in from kind of any server. So that's one of the ways in which these MFA bypass kinds of attacks happen. Let me move on. All right. So what do you do? So let's talk a little bit about implementing a phish resistant option, and what one of the key things in doing this is really taking the human out of the loop. My God, have we put a lot on humans with when it talks about access and authentication, right? We made them choose passwords, lots of different passwords, a new password for each different server. We made them quote unquote, choose a long and strong password. By the way, that's a myth. The long and strong password, it doesn't matter. It only matters if it's 12, 14, 18 characters and some special characters, and if we're trying to crack the passwords. But that's not the way bad guys get them. They steal them while they're in the clear, while they're being typed into, to a login screen. If I've got a man on the endpoint, or we'll use this proxy-based attack to grab them right off of the network. So, I don't need to crack passwords to actually get passwords to log in. So this idea of long and strong passwords is a myth that unfortunately remains. But yeah, we're putting the burden on those guys. First of all, they go to log into the server, and the browser can validate that the server is has a certificate, but that doesn't necessarily validate that it's actually the server that the user thinks they're trying to get to. Using we can create pretty interesting URLs that look very legitimate, using even Cyrillic characters, or just using different naming conventions that look legit, and we can stump the human, as we showed. Even in our scenario, you're going to get with our know before and all the training that we do, or that you guys do, people are going to not necessarily recognize a phishing link, a URL, and they'll click on it. So then the human executes the auth protocol. So this it puts a lot of it in the human, and the way we think about it is, let's let the machine do the work. So one of the things you can do, for phishing resistance is, well, there's a couple of pieces. So the first piece is really anchoring the credential in hardware, and specifically in an enclave or TPM, trusted platform module. And what we're talking about is putting a key in a specially designed separate part of the computer, and they're available on all modern devices, whether it's my iPhone. Kind of ever since the iPhone 4 came out, and we were using the fingerprint reader on the iPhone 4, Apple, for example, in its infinite wisdom, decided, hey, putting fingerprints in an Apple server, where it paints a target on them, probably isn't a good idea. Maybe we need a secure place to store those things, where they can't be moved. TPMs were used for lots of other things, including validating different pieces of the operating system, as they loaded up. But they're also now being used to store credentials and biometrics, et cetera. So we can use that same thing to store a private key. So that's a piece of it. It's not, if we do it that way, those keys aren't accessible in memory. They're not accessible in disk, et cetera. The second piece of phish resistance is really making sure that credentials don't move. If we take a credential and move it across the network, as we saw in this man in the middle kind of attack, that's when it becomes exposed. And people think, well, wait a minute, we've got TLS to give us a private connection between an endpoint and a server, or an application and a service that we're trying to get to. Why isn't why doesn't that solve it? And the answer is, those credentials pass through all kinds of various services and third-party things. For example, they'll likely pass through a CDN network, something like Cloudflare or AWS CloudFront. They're going to likely cross. And by the way, in those cases, we're opening we're opening up the TLS connection and re-terminating it. Same thing if we go through the load balancer from like AWS or an F5, or when we're not just talking about a server. The service is really based on like a Kubernetes cluster, for example. Same thing. We've got containers that are going to open up and re-terminate the TLS connection. So there's lots of different places along the way that either the bad guy could hack into and get access, and we're not even talking about the proxy, based attack, or somebody at one of those service providers, a malicious employee, for example, an insider threat. So whether it's an external malicious threat or an internal malicious threat, both of those are open, and there's just lots of places. So we want to make sure that we anchor those credentials in hardware and the TPM, and we want to make sure that they don't move. What does move is we can sign a certificate and send that over, and then we can prove that that certificate was signed with a private key that matches a public key that we can keep. By the way, that is how TLS works. So how do you extend that? Above TLS, what we need to do here, is not only make sure that we've got a TLS connection, but we have to have an application level signing ceremony so that, for example, the way we do it is we've got a platform authenticator, a piece of software that runs on whatever you're trying to log in from, and we've got our backend cloud. Our cloud initiates that request to the platform authenticator. Our platform authenticator can validate that the domain it came from, is the one that has the key or is associated with a key that's stored in the TPM. So those are things that we can document. And what that gets called, this idea of those sets of validations is what the government calls in like the NIST documentation, I think it's the 863, is verifier impersonation protection. And that means that, you can't impersonate a service, therefore you can't get man in the middle, for example. So and that's a big piece. There's two things with modern MFA that are a problem. The keys, the credentials move, and they're not verifying the folks requesting the authentication, as we saw in the Microsoft example that we went through. So what we think about is eliminating whole classes of root cause, of things. That way, you can't stop phishing emails from happening. You can't stop, our employees or customers from clicking on those. Can we make the action of clicking on those moot? Like it doesn't do anything. So where we started was in the idea of credential theft and going passwordless. And then we, focused also on, in fact, this was kind of by design from the beginning, blocking these arbitrary phishing attacks, adding, adding the, phishing resistance to our MFA. So we only use, in our case, we only use factors that are strong, and we're not susceptible to the man in the middle type of attack. We've done the verifier impersonation work that we need to. There's still a class that we've got to pay attention to. So we've done, credential theft. We've done the phishing, kind of the man in the middle attack. But what if my host is compromised? What if the endpoint itself is compromised? So making sure that we take care of that, set of use cases is what we started working on, and we've got some more work to do, as does the industry. So what might that look like? That's what we, those sets of things are what we have lumped in and called Zero Trust Authentication. So it's a combination of phish-resistant MFA, device trust, and then continuous authentication and validation. So, we protect with credential theft by having credentials that don't move. We protect with this session theft with this verifier impersonation resistance, and we protect malware delivery. We can't, by the way, those first two things can stop whole classes, rather than making it probabilistic, they can stop a whole class of attacks in their feed. Is it going to stop every attack? No, but very large and very often used by the bad guy set of attacks, as we talked about earlier. And then there's malware delivery. If I get malware on the endpoint, might I have a problem there? And there's some things that we can do there, even as part of the auth transaction. But one of the things we can do is make sure that the appropriate controls on the device that you're trying to log in from are in place, so that it's much harder for a bad guy to actually get to deliver malware to that device. So it's a combination of those things. I just kept this slide in from a prior deck, a little bit for fun, because when we started playing around with AI and asking it to create us images of what these things might look like, this is what it came up with. So for passwordless and phishing resistant and device trust pieces, AI did a pretty good job. These are not our images; these are actually AI generated things. So clearly it's advancing quite quickly. So let's talk about literally what might this set of things look like in action. So now I'll go into, switch gears and go into kind of what we're doing, specifically at Beyond Identity and how we kind of work in this ecosystem. So what I'll do is I'll take you through this authentication flow, graphically, and talk to you about what happens, and then I'll demo what actually goes on in practice. All right. So the first thing, I'm sitting at my laptop and I'm trying to get access to one of these applications on the right. Most organizations have an IDP or a single sign-on in place. Those platforms, whether it's Okta, Microsoft, or at all, have a capability. It's actually part of the OIDC standard for delegated authentication. Which basically means let me hand off the auth piece of the flow, to a separate service. So that's what they do to us, and then we validate two things. Is this an authorized user? We do a public-private key. We basically exchange the certificate signed with the private key that is on the device in the enclave, and check that against the public key that's registered in our cloud. So that gives us a very high trust whether this is an authorized user. And there's other factors we can add to that, and we'll show you that in a minute. But then we also check the device security posture. Are the controls in place that you want to see in place? Is my firewall on? Is my disk encrypted? Are the pieces of software that we're using to protect us, whether it's things like CrowdStrike, EDR, types of technology, MDM technology, are they implemented and running at the time of authentication, for example. Next, that's a pretty good start, but a lot of organizations have made a hell of an investment in a lot of technologies. What if we could use signals from some of these technologies that are often used either for configuration, or for detection and response? What if we could use those signals, those risk signals, to make a better, more informed decision about whether we ought to let, me or the device I'm using, have access to the application that I'm requesting to? So that's what we do. We check those risk signals, and we'll show you that. And great, if everything pans out, we grant access and we move along. Now, that's really interesting, but one of the issues with Zero Trust, and one of the issues that we've had with authentication, heretofore, is we often will grant a session token that's open for, at least hours, sometimes weeks, and we've actually run into with a couple of our customers that will go unnamed, session tokens that they keep open for a month. Mostly because the authentication process was such a pain in the ass, they didn't want to put the end users back through it. They kind of, they rallied and got them to extend those session things so that they didn't have to do that again. And we all know, we've been, anybody listening in, I'm sure, has been in cybersecurity long enough to know that, an hour or a day makes a lot of difference. Things can change on the endpoint. Malicious, something malicious can tap into it. I can turn off the control. Something can just stop working. One of my controls in places, can get turned off, et cetera. So the way we think about this is, don't just do an authentication, then continually recheck that, recheck the authentication side of it, your user behavior signals to see if anything's changed there, recheck device security posture. And if anything bad happens and we've got an issue, then do something about it. This is taking a page kind of from the New York subway. If you see something, say something, right? In our case, is if you see something, do something. Let's quarantine the device, for example, or drop the network connection so we isolate it so that if somebody has a chance, if there's a bad guy on the endpoint or potentially a bad guy let's isolate that so that they can't do what they want to do, which is move laterally in your network and get to, in a higher order target, so that they can't do the damage. So what we're thinking about here is prevention. We all know prevent, detect, and respond, and we spent a lot of our budgets on detect and respond, kind of appropriately, when the bad guys were in there and their dwell time in our environments, ranged from weeks to months. We obviously had a big problem, and we spent a lot of money taking care of that. But it's a whole lot better to prevent classes of attacks that you can prevent and stop them in their tracks. That way, your security operations center and the SOC team can focus on other issues, other classes of attacks and things. So that has a lot of byproducts. The last piece of this is obviously write this out to, we write out a set of immutable logs so the Security Operations Center, and whether it's integration with Splunk or kinds of tools, or Snowflake, types of analytics, data analytics tools, provide that information, both the positive and negative events, so that they can be used in reviewing incidents in the future, or even narrowing your search surface, so that the security operations team can be better at what they do, because they don't have to look at they can take some of the things off the table. And then, also say that information, add it to your governance and compliance tools, so it's really easy to prove that you're complying with all these things that you're being required to comply with. All right. So that's what it looks like on paper. Let me actually bring this over, and wow, we're looking at me. I am going to first, we happen to be, just to kind of give you a perspective, I'm actually going to go through an authentication flow, and then we'll jump into the back end of the system and kind of see what happened. We happen to be an Okta customer. We're using Okta as our IDP. We're also a partner of Okta's, and very happy with that product. We use CrowdStrike, kind of across our fleet. We use Intune on our Microsoft fleet. We use Jamf on our Mac fleet, which I'm part of, et cetera, et cetera. So let me first, just do a quick log out here. So here's a state. I've, opened my computer, this morning. I, fingerprinted in, which gives me access to the different applications that, the tiles on my desktop, also gives me access to log into Okta. In this case, that's what I'm going to do. You'll see that there's only space for a username. There is no password. That's not something that we do, because we've just eliminated that as part of the authentication list. We've just pulled the password, all the way out. We're using a cryptographic, public-private key exchange to do that. So let me go ahead and go through this. I'm going to click next. We'll start the process. You'll notice I've got a Beyond Identity Authenticator here. It's asking me now to put my finger on my fingerprint reader on my MacBook Pro. I do this, and then I'm in. So a thing to note, and we didn't talk about this at all, is you not only want to make this secure and take the user out of the loop, which we've done, you also want to make this be patently simple and easy and frictionless for users. So I'm not going to dwell on that, but it's something that we really pride ourselves on. We made this authentication flow something that, everybody, in fact, one of the downsides of working at Beyond Identity is, if you ever leave and go take a job someplace else and they don't have this, you're kind of, you feel like you went back in the dark ages. So now I'm into Beyond Identity. I'm going to go ahead and log into the admin console and just give you some idea of what happened and what kinds of policy evaluations happened. So you can actually see, live. So we've got, as any console, we've got some insights about, kind of what's going on in our environment. I'm going to go directly into the event log. Actually, why I'm doing that, I've got my iPhone with me. I'm going to go ahead and sign in from my iPhone as well into my Okta environment, because I want to show you a couple of other things there. So I'm authenticating. It's now taken my, biometric, my face print, and now I'm in. You guys, I didn't plug this one in, but you can take my word that I'm logged in, and you'll see it actually show up in the log file. So if I go into my events log and I search by user, there's only one Patrick at the company, so don't have to be that. So we got a couple of logins here. This was the one that I just did for my Mac, but let's first take a look at, the one I just did for my iOS, my Apple device, my iPhone, and then let's take a look at my my MacBook login. So I'm going to click on this, and one of the things that you'll see is which policy fired and which one actually let me in, and you'll see this is the rule that actually fired to let me in. So what did it check? First of all, am I on a Mac? Yep. Am I doing an authentication transaction? Yep. Is my user firewall turned on? Basically disk encryption. Is my firewall on? Is this a work issued device and managed by Jamf? It is. And is that Jamf connection available? If it wasn't, we can run it through different policies. So this, the one interesting thing here that I will note, and anybody that spent time grepping through logs or trying to sort through logs and figuring out when something goes bad or something goes good, we kind of, our policy team is, some of the best in the business. We make this evident. You don't have to go browsing through or grepping through logs and sorting through logs. Our log file tells you exactly what happened, specifically, and how all the other rules were evaluated. But let me come back to that. You'll see, get back into user. And we'll see that this was a login, a different rule. This happened to be a login. It was an iOS, and this is the one that allowed me to get in. There was a bunch of other rules were evaluated, but this is the one that matched and let me in. So let me go a little bit deeper into our rule sets. We've got a bunch of rules in our policy framework. We're actually consolidating some of those now, for our own policies, and obviously for any of our customers, you can customize this just to what you want. But let me run down, and we'll talk about the Mac OS stuff. And I'm going to look at Rule 23 that let me in. As we said, it was a Mac OS. We're doing an authentication transaction. The firewall was on, Jamf was on, and the action was allow. And as you'll see, allow with OS verification. You'll recall it made me put my fingerprint back on my reader. Hey, great. I came in the morning and logged in either with, if I was turning on my machine, I'd have to type my PIN code. If I was just, reopening it after the lock window came up, I can just put my finger on the reader. But what if I'd walked away, from my desktop, and left it alone, before we allow somebody to get into the Okta environment, for example, and get access to all those applications, we want to make sure that it's still the right person behind the keyboard. So that was an interesting one. Let me, and nobody needs to be afraid here. I'm going to do a little policy editing. The good news is that my security teams give me access to this. The better news is that I actually can't publish any changes to the rules. So I can mucks around in the sandbox and still not screw anything up. But let me look at a rule. So let's call it, the potential threat found. So, here's what rule development looks like. So I'm going to look at specifically authentication rules that I could apply it if I'm adding a device and, a new device to the mix. But let's focus on the authentication. Let's say any user, let's look at it for the Mac. And let's take a look at, instead of Intune, we'll go CrowdStrike. What if the Zero Trust score is greater than, say 80 points? By the way, we're monitoring this now ourselves so that, we're figuring out actually where to set this. So CrowdStrike Falcon produces, one of the things it produces is a Zero Trust score. It basically gives you some assessment of, whether they think, the likelihood that device is, compromised or potentially compromised, or something, fishy is going on. So I can do that. I could add other attributes as well if I wanted to. I can add a series of those things, so I can chain some things together, and then I could allow with OS verification, or let me get my right rule here is working in the wrong place. Add action. Deny. I can deny, I can monitor, I can allow, I can do all these things, or I can actually have CrowdStrike, adding this. We can look in different regions, all of those things. So I can deny, or I can also change this to, not just deny, but quarantine the device. And it's hidden under one of these things that I have to get my policy building skills a little bit better. But, I can, if it's greater than 80, then I can, I can take an action or check other things, et cetera. So I've got deny, I can monitor, or I can allow it, et cetera. So with that, you get some idea of the granularity and the integrations that we've included. Now, let me go back and I'll take a look at the. I had my iPhone login as well. That was the second one. Now, again, we're going to pivot right into the thing that let me go. So this was Rule 43 that actually let me in. You'll see, we'll scroll down to that. Rule 43 let me in. But you could see, for example, if I was trying to log in to an iOS device and it was either or trying to add an iOS device and it was jailbroken, we could deny it and say, hey, no way. We're not going to let you add a new device that's already jailbroken. I could also make this, instead of add device, authentication, for example, and then, whether I'm either adding a new device or trying to authenticate. Let's say I add a device, everything was copacetic, not a jailbroken device. Subsequently, I go and, because I wanted to get some interesting new game, I jailbreak the device and then try to log in, we still get a no. And there's obviously other different factors that we can change. And the last thing I want to show here in the demo is just this idea of continuous. Oops. Search by user. All right. You'll notice, we've got the allow policies, but we've also, and this was from earlier authentications, you'll notice it's about, it looks like we're doing it about every 20 minutes, every 10 or 20 minutes. We're going back and reevaluating those same policies. So I authenticated in, we did a bunch of checks, and I got an outcome. If something changes in the meantime, I turn off my firewall, for example, or I unencrypt my disk, or I jailbreak my phone, et cetera, we're going to look at this in 5 minutes, 10 minutes, et cetera, on a continuous basis. And or I change location to some new location that that wasn't authorized. Any of those things happen, I can now I've got some choices. I can quarantine the device. I can knock me off the network, et cetera. So the idea of if you see something, say something. So with that, I will stop. But that's what we think about, when we're talking, zero trust in action and going through these. This isn't theory. And I guess a couple things to point out. When you take a look at that at face value, it seems like, well, wow, maybe that's a heavy lift. Maybe that's a lot to do. In reality, and this is shocking, and I'll have to take my chief marketing officer hat, put it on the hat rack, and talk to you with my former been on the other side of the tracks hat. We can actually get an Okta environment, for example, up and running. When we do a POC, very often we'll schedule an hour to do that. We'll end up having a team of 4 or 5 people on the phone, and we'll get that configured. So, we've got to share some keying material between, Okta and our cloud. So our cloud can talk to our cloud, or more accurately, so Okta can delegate that to us, and we, through the transaction. So there's some of those things to do. There's a download the authenticator. The end user can download it, or you can push it, through MDM, to your fleet like you do with the rest of your software. But, we'll get, 4 or 5 guys on the phone or gals on the phone, and within a half an hour, they're already doing authentication transactions. And since it's not a nice switch, we can just, take the 4 or 5 people that, want to do a POC, put them in a special group, the Beyond Identity Authentication group, let everybody else do what the organization do whatever they were doing, and let them try it out. The integrations are, pretty push button. It's click the integration you want, and then it becomes available in the policy engine. And as you saw, the policy configuration is, a set of selections. What we didn't show there is the ability to create your own kind of policy checks. There are some things you can check for certain running processes. You can check with, is something installed, like is there a specific key in the registry that you would want to look for? Or is a particular process actually running at the time of authentication, or at the time that you're adding the device, et cetera. So we didn't go for the depths of the policy engine, but it's really, these integrations are out of the box things that we've done and made available to you. And so the lift is not heavy. Now, having been again on the other side, that doesn't mean that it's we just turn it on and fly. Obviously, there's an education period. There's starting to build your policy, your policies out. and make sure that we've got those in the right order. And we and some of our integrator partners can help you with that. But again, it's not a heavy lift, and we can go from take you from really phishable MFA with no ability to check the device, with no ability to grab signals from other products, to that state where you can get full zero trust version of authentication in a very short period of time. So with that, I'm going to stop and let me hide my screen, and I think we might have some Q&A here. All right. Okay. Yeah, we've got a bunch of them in here. That's great. So requirements to implement something like Beyond Identity is the first one, and in that case, we work with an IDP. So a single sign-on product, like the ones that we mentioned there. A lot of our customers are using Okta. A lot of our customers are using Microsoft Azure AD, or even on-prem, some flavor of both Azure AD and traditional AD, for example. And so that's a piece of it, and that's really the only requirement. We integrate with that. If you've got other kinds of technologies that we can pull signals on or signals from, then we can do those integrations. But you can do that at your leisure. It's not something that you have to do right up front. So can we use Zero Trust Authentication to authenticate customer logins to our own product? Oh, that's a great one. Yeah, I spent all the time really in the demo and talking about our secure workforce customer. So that was oriented at allowing employees or even partners and things like that need access to the application suite that's part of your internal environment. But we can also take and help you implement, FIDO passkeys for your external environment, as an example. So, if you've got, the classic example of a banking application or a consumer application that you've provided, we can take those things passwordless and have secure phishing resistant MFA. Interestingly, both are now requirements in the U.S. federal government. When we started out with this idea of a risk-based case for zero trust authentication, and particularly passwordless and phishing resistant, the U.S. government has mandated for all the systems that it has, that the U.S. government employees have access to, that they are, by the end of 2024, have phishing resistant MFA installed. It's not like maybe, kinda, it's shall. They use the word shall have that. And for all the external applications, maybe like the IRS application that we might log into to get information, about our taxes and stuff, those all in end of 2024 shall have a phishing resistant option. And that makes sense. They're not pushing them, all the way to turn on for everybody, this new style of authentication, because that's, a couple of 100 million that may have access to some of these applications. So they're giving them a little bit more time. But that shoe will drop too, and then they'll convert. Why do they do that? Because CISA's looking at exactly how the attacks are happening. They're looking at the threat vectors that bad guys are coming into, and they know they can shut off a couple of those threat vectors by doing that. I'll take one or couple of why are other passwordless solutions like Okta FastPass not considered zero trust authentication? We don't believe they're full zero trust because they haven't in some cases. It's not just Okta, Duo and others. They haven't all. They don't only use factors that are strong, like crypto-based, public-private key. A lot of those will implement factors that are easily stolen. And a big piece is they move keys around, and they haven't established this idea in many cases of impersonation, the verifier impersonation checks that we end up doing, and that the U.S. government calls out in their documentation. How would you answer someone else? Oh, how are we different from Microsoft Hello for Business? A couple of things. First of all, in order to have, you can use Windows Hello for Business, but if you want to get things like they've also got conditional access. So if you pair those things together, it's close. But if you want to be able to provide, for example, that across your entire fleet of employees plus contractors. A lot of organizations have contractors. We can do that without requiring you, for example, to have Intune. For a lot of that stuff to work in the Microsoft environment, you have to have Intune licenses for a lot of these other things. So that's one. The continuous authentication that we do is another. We're always, when we do that authentication transaction and pull data, we're always pulling fresh data. So it's a combination of a couple of those things. See, I've got a couple more here. What I can do is, since we're a couple minutes over, any of the following, any of the remaining questions that we didn't answer, we'll get back to the people that answered them and drop you answers as we do the follow up email. We'll send a copy of the presentation for you and a copy of the recording if you'd like to share that with colleagues. And by all means, if you've got one thing that I did forget, I'll do a quick share again. Is Yes, let me share the entire screen. We've got a book that is a really worthwhile read. So we pulled all this together in something we call the Zero Trust Authentication framework that we build out and work and had a book done. So you can just go to our website or search on it, or QR code with your phone here and grab that and get a copy. Hey, if you'd like a hard copy, we'd be happy to send that to you. So just ping me. My email is there. It's firstname.lastname@beyondidentity.com, or you can hit me on LinkedIn. If you'd like a copy of that, or if you've got any other follow-up questions, or would like to request a demo and do a deep dive, with your more specific tech stack in place and your use cases, we'd be happy to do that. So, don't be shy with that as well. With that, we'll end the webinar. I thank you for all taking some time out of your very busy days to join us, and we hope to talk with you in the near future. Take care and have a great day.